These are the quiz corrections for our volume, surface area, and density quiz. So first question says, calculate, state the following measurements about this trapezoidal prism. 1A, height of the polyhedron. The height of the polyhedron is the perpendicular measurement between the bases. So this is 30 centimeters. The height of the base is going to be the height of this trapezoid, in which case this picture is giving us that as 8 centimeters. The area of the base is going to be the area of the trapezoid, since this is a trapezoidal prism. Area formula for a trapezoid is the average of the bases times the height. In this instance, this would work out to be 9. Here is one of the bases, plus 17 divided by 2 times the height, 8, which is 104. And since we're dealing with area, this would be centimeters squared. The volume formula for any prism is the area of the base times the height of the prism. So we are basically going to be taking the area of the base, 104, multiplying it by the height of the polyhedron, 30, and that will provide us with the volume of the trapezoidal prism. In this case, that would be 3,120 centimeters cubed. So we have first dimensional units of measure for heights. These are centimeters. Second dimensional units of measure, areas, centimeters squared, and then third dimensional units of measurement for volume, that's centimeters cubed. The surface area is going to be calculated by using a net. If this is the top of the polyhedron, this will be the top of my net, and I will have the bases on either top and bottom of that. If we call this a side, then our net will have 2 sides, one on either side of the top. And then even though we can't see the bottom, we know there's one there, and so we'll have a bottom. Okay, so by using our area of a rectangle formula, which is length times width, I will be looking at things such as 17 times 30 to find the bottom area. This side would be 10 times 30, as well as this side. The top would be 9 times 30. And we already have the area of the bases, so I'll just add those in as 104. That gives us a surface area of 1,588 centimeters squared. Okay, moving on to the volume of a hexagonal pyramid. The volume of any pyramid is 1/3 times the area of the base times the height of the pyramid. In this case, our base is a regular polygon, so our volume formula would be 1/2 SAN times the height of the prism. So as we rewrite this, filling in all known information, it's 1/3 times 1/2 times S, which is the side length, that is 8 meters, times the apothem. The apothem is the measurement from the center of the polyhedron perpendicular to the side. I can call that A for apothem right now. We'll get back to that in a minute. N is the number of sides. This is a hexagonal pyramid, so that would be 6 for hexagon. And then our height of the pyramid is 17 meters. So we are ready to calculate this as soon as we find the length of the apothem. As I redraw the base of the pyramid as a regular hexagon with the apothem written in, we'll note that the side length of the hexagon was 8. However, in order to solve this particular style of problem, we're going to build a right triangle using a radius of the regular hexagon, the apothem, and then half the side length. This is a perpendicular bisector, cutting this into 2 different pieces, so we have a 4 down here. Since we cannot find another side length of the triangle, we're going to instead look for this angle measurement. We'll start by finding the angle measurement of a regular hexagon using the formula n-2 times 180 divided by n. Once we know this measurement right here, which happens to be 120 degrees, we'll cut that in half since the radius is a angle bisector, giving us a 60-degree angle for our right triangle. Redrawing that right triangle would look like this. 60-degree angle. Our apothem is here, and we have half of the 8, which is a 4. Because 30, 60, 90 triangle is a special right triangle, we have formulas that we've been using all year in class to find the length of the apothem. This allows us to skip the process of using the Pythagorean theorem, skip the process of trying to estimate with trigonometry, and we know that this is x radical 3, in this case 4 radical 3. So once we've identified the special right triangle and we've identified the apothem, we can jump back up here and write in 4 radical 3. When we multiply all of this information, we're going to multiply 1/3 times 1/2 times 8 times 4 times 6 and times 17 using the commutative and the associative property of multiplication. When we do that, we'll find out that that is 544, and then our square root of 3 goes on the end, much like a variable. This is called simplest radical form, and this is the exact answer. The instructions at the top say all answers on this quiz must be exact answers or rounded to the nearest hundredths place when necessary. It was not necessary to round here since we could, thanks to our special right triangle, come up with an exact solution. So all we're going to do to finish this problem is write it in the answer line, 544 radical 3, and then use our units of measure, meters cubed. Moving on. In this particular volume formula, we are given the volume and asked to find the radius. So we'll start with the volume formula. The volume of a cone is 1/3 times the area of the base, pi r squared for a circle, times the height of the cone. We'll fill in all information that we can. Our volume is 2,560 pi. Set that equal to 1/3 times pi times the unknown radius squared times the height of the cone, 30. We will build walls separating the left side of the equation from the right side of the equation, and we will use algebra until we can isolate the r variable. So the first thing I will do is divide both sides by pi. Dividing both sides by pi simplifies our equation. We are now looking at 2,560 equals 1/3 times 30. 1/3 times 30 is 10. So I will simplify the right side as well. 10 times r squared. After I've divided both sides by pi, I will now look at undoing our order of operations. So I'm going to undo multiplication with division. I'll divide both sides by 10. 2,560 divided by 10 is 256 equals r squared. And continue to undo the order of operations by square rooting both sides. The opposite of squaring is square rooting. Now, when we get down to this final answer, we may be thinking that the answer is both positive and negative 16. The square root of 256 has two answers. However, because this is a volume problem, we're working with positive measurements only. So our final answer becomes 16, and then this is a first dimensional unit of measurement, and we will go back to our first dimensional unit of centimeters. That is the final answer. Okay, now we'll go to page 2 of our surface area, volume, density quiz review. On the back, we began with a surface area of a triangular prism. So since we're dealing with surface area, I'm going to draw a net. The net will contain the bottom. Nets can be drawn in a number of different ways. I'm just choosing to draw it this way. We'll use the front and back, which are triangles. And then we have a left and right side, and I will attach those to the edges where they are connected with the original shape. So, as we are looking at that, we are going to be thinking about the area of the bottom as a length times width problem. This is 16 times 20. 16 times 20 is 320 meters squared. I'm just going to write the 320. The left and right side are 20 by 10, that's 200. So I have 200 on one side, 200 on another side. To find the area of the triangles, we have to use the area formula for a triangle. The area of a triangle is 1/2 times the base times the height. In this particular situation, we have 1/2 times the base of 16 times a height that was not provided for us. However, we're looking at an isosceles triangle. And when I drop the altitude of an isosceles triangle, I'm also creating a perpendicular bisector. Because of that, I can confidently know that this 16 is being cut in half to give us a right triangle that has a hypotenuse of 10 and one leg of 8 meters. Now, knowing that 3, 4, 5 is a Pythagorean primitive, and similar triangles, such as multiplying each of these lengths by 2 to 6, 8, 10 gives us a Pythagorean multiple, I can tell that this leg, without the Pythagorean theorem, is a height of 6 meters. 6 squared plus 8 squared equals 10 squared. That is a Pythagorean triple. So, with that in mind, my height is now 6. 1/2 times 16 is 8, and 8 times 6 is 48, giving us 2 more areas. Once we add all of these together, we have a final answer of 816 meters squared. This is a hemisphere. The volume formula for a hemisphere is 2/3 pi r cubed, and the surface area formula for a hemisphere is 3 pi r squared. By substituting 9 in for the radius in both of these and keeping our answer exact, we would be able to calculate the volume to be 486 pi. This would be centimeters cubed, and the surface area as 243 pi centimeters squared. We are leaving the pi symbol as the pi symbol since we are looking for exact solutions. It acts as a variable. Okay, our very last mandatory problem on the quiz was to calculate the approximate area of a regular pentagon. So we are going to draw, as best we can, a regular pentagon. It has a side length of 6. We're going to build in our apothem once again, and our triangle that we use for area equals 1/2 times the side length times the apothem times the number of sides. As we write in our side length of 6, realizing the apothem is going to take a little bit more work and the number of sides is 5. Once again, we are looking at finding that apothem length. So as we do this, we are going to use this same formula, n minus 2 times 180 divided by the number of sides, to learn that the measure of one interior angle of a regular pentagon is 108 degrees. And when we cut that in half to find the measure of this right triangle, we find that that's 54 degrees. Once again, redrawing that right triangle that we've created, cutting the 6 in half to 3, because we do have a perpendicular bisector, writing in a 54 degree angle, and looking for the apothem, which I'll call x here for a moment. We realize that this is a trigonometry problem. So we're going to put our finger on the angle, 54 degrees, and we are going to think about this being the opposite side of my finger and this being the adjacent side of my finger being the acute angle we're working with. So opposite and adjacent is the tangent function of trigonometry, and we will write the tangent of 54 degrees equals the opposite side over the adjacent side. We will multiply both sides by 3 to get x by itself, and x will be 3 times the tangent of 54 degrees. This is approximately 4.1291 inches, and we are going to round this out to 4 decimal places so that when we actually multiply this number times what will be 1/2 of 6 is 3, 3 times 5 is 15. When we multiply this by 15, we don't get 15 times the error at the hundredths place. So multiplying this with 4 decimal places of accuracy in the tangent function would give us 61.9371 inches squared, and the instructions, as you'll recall, say that we need to round to the nearest hundredths place. So if we're going to round to the nearest hundredths place, we look one space to the right, In the thousandths place, this number is indeed 5 or higher, so we're going to add 1 to the 3 100ths, and that would give us 61.94 inches squared, which is accurately rounded to the nearest hundredths place. Okay, the leftover piece is extra credit, which I will leave for another YouTube video as we are running along. Thank you.